brand new channel. So in this live class, I'm going to explain about magnetic effects of electric current. So in this class, I'm going to explain about magnetic effects of electric current. Hi everyone, welcome to the Student the Brand. Shiva sir from Student the. So hi everyone, we can check. So today a very important topic, very interesting topic, magnetic effects of electric current. Magnetic effects of electric current. So you can see 9 o'clock class. So at 9 o'clock, I'm taking live class. 9 o'clock, I'm taking live class. So in the 9 o'clock class, okay. So we'll be having we'll be practicing the electricity chapter. Problems we are working. From past few days onwards, we are continuously working on electricity. Past 2 days onwards. So nearly this third day, if you are going to that. So problems we are working, and chapter also completed. Chapter explanation. Those who want explanation of the chapter, just let me know. I will work out on it. Electricity chapter. Those who want explanation of electricity chapter, so you can join to the live class and you can comment. So or you can generally, in this class you can join and comment if it is required. So now we are working on magnetic effects of electric current. Okay, and you can see I started the course CBSE Grade 10 Physics. Okay, light reflection and diffraction, human and color flow, magnetic effects of electric current, and the electricity chapter. These 4 chapters. Okay, along these 4 chapters explanation, I am going through that 4 chapters explanation. Along with the 4 chapters explanation, 100 problems will be given. So along with that 4 chapters explanation, soft copy of those 4 chapters and 100 definitions, 100 definition notes, and 100 problems from electricity chapter, 100 problems from electricity chapters. This all I'm going to provide. Okay, so in the class. So while after explanation of each and every topic, after completion of that, so we are working on it. So those who need this explanation, so those who want explanation of these 4 chapters, HRG, hi, welcome to the class. Okay, so those who want explanation of these 4 chapters, so along with the explanation, notes also I'll be providing. What language is that? I'm speaking in English. So, are you understanding or what? So, I'm talking in English. So, I hope it is clear to you all. Is it clear? So, my voice is not clear to you all? Or let me know. Is my voice is clear or not? Let me know. Okay. So, if it is okay, I'll continue with that. If not, I will increase the volume. Okay, so we have buttons. No, normally if you see the mobile, so we have to increase or decrease, but we no need to increase or decrease. We no need to click on the buttons. Naturally, we can increase our volume. So let me know if it is clear or not. So whatever I'm speaking. Oh, I need to go. so I'm going to the magnetic effects of electric current. So in the magnetic effects of electric current, so today we are going to discuss about completely about a magnet. Okay, so first we will discuss about magnet. So artificial magnets, natural magnets, artificial magnets, and natural magnets. So about that, and magnetic property. So magnetic field lines, and next one after that. We can say bar. If you are taking artificial magnet, bar magnet, about bar magnet we will explain. So bar magnet, after completion of bar magnet, So we will find out the magnetic field and field lines properties, magnetic field and field line properties. After the completion of magnetic field and field line properties, so right hand thumb rule, right hand thumb rule. Okay, so by using right hand thumb rule, so next we are going to the current carrying through side conductor, current carrying through side conductor. After that, a current carrying through loop, current carrying through loop. So loop we'll discuss. After that, we will work out on solenoid. Solenoid will work out. So we'll work out on solenoid. After the completion of solenoid, that is nothing but electromagnet. Electromagnet. So after completion of the solenoid, we'll go to the Fleming's left hand rule. Fleming's left hand rule. Fleming's left hand rule. After completion of Fleming left hand rule, we will work out on current carrying conductor placed in the magnetic field act as experience the force. Current carrying conductor placed in the magnetic field experience the force. About that we will discuss. Okay, so now we will work out on it. So I'm going to the explanation part, so you can check now. So I'm taking here magnetic effects of electric current, magnetic effects of magnetic effects of electric current, magnetic effects of electric current, magnetic effects of electric current. So we are going to discuss about this topic. So first point we are considering. So here I'm considering the magnet. So types of magnet types. Second one, after completion of types of magnets, bar magnet, and magnetic field, everything. And third one, we can see right hand thumb rule, right hand thumb rule. So we will talk about right hand thumb rule, right hand thumb rule, and the next one, fourth one, right hand thumb rule will explain. Next one, we are going to the side conductor, current carrying through side conductor. Next one, solenoid. Okay, so these are the points we are going to discuss in the today class. So you can check once. So here I am talking about magnet. So types of magnets: bar magnet, right hand thumb rule, so side conductor, solenoid. So we'll discuss all these points. So now you can see the magnet. So magnet is a substance which has the property of attracting the magnetic materials. Magnet. So magnet is nothing but, so it is a substance. So magnet is a substance which has a property of attracting the magnetic materials. Magnet is a substance which has the property of attracting the magnetic materials. So there are two types of magnets are there: artificial magnets and natural magnets are there. Artificial magnets and natural magnets are there. So natural magnet. So magnetite is a natural magnet. Magnetite. Okay, so magnetite. So magnetite is a natural magnet. Magnetite is a natural magnet. Okay, so we can go with that. Lodestone. Natural magnet is also called lodestone. Natural magnet is also called lodestone. Okay, natural magnet is also called lodestone. Okay, so next one, artificial magnets. So artificial magnet, there are a bar magnet, horseshoe magnet, dumbbell shaped magnet, bar magnet. So we can take a bar magnet. I'm considering bar magnet. So first one is bar magnet, second one is horseshoe magnet, dumbbell shaped magnet, like that. So many are there. So different types are there. So coming to the artificial magnets, these are artificial magnets. So magnets are made by the humans. Magnets are made by the humans. Those are called artificial magnets. Artificial magnets. So normal magnets, if you consider natural magnets are, so we can take magnetite. Magnetite is the natural magnet which occurs from earth crust, which occurs from earth crust. So live class will be there at 9 p.m. So every day. So you can join to the live class. So we'll be getting the, today I am taking the electricity problems in the live class. So join to the class so you can get the clarification. You can ask the doubts, okay, from the electricity chapter. So that is about electricity. Now I am considering the bar magnet. So artificial magnet, bar magnet, U-shaped magnet, dumbbell shaped magnet. So like that, many types are there. Many types are there. Many types I'm considering. Many types I'm considering. So here, magnet has magnet has property. Magnet has property, attractive property and directive property. Attractive property and directive property. So attractive, if you are considering attractive property, attractive property, attractive property. So what are the attractive property? So magnet has two property. So magnet, so magnet has two property. Magnet has two property. One is attractive property, attractive, attractive property, and second one is directive property, directive property, directive property. So I'm considering the directive property, attractive property, and directive property. So what is attractive property? Attractive property is nothing but, so the substance you can see. Here if you are taking the magnet, so I'm considering the magnet here. I'm considering the magnet like this. So this is the north and this is south. So I'm considering here also magnet, here also magnet. Here I'm taking a north and here south. So two similar poles will attract each other. Two similar poles will attract each other. Two dissimilar poles. Dissimilar poles means north will repel. So first point, north will repel. Second point, south will repel. South will repel. North will repel. So north and south will attract. South and north will attract. Okay, so here we can take this is the property of the magnet, that is the attractive property and repellent property. And coming to the directive property, if you suspend the magnet always, if you suspend the magnet always freely, if you suspend always, it shows north and south direction. So if you are considering always, it shows north and south direction. Always magnet shows north and south direction. So if you are taking here north, south, east and west, north, south, east and west. So if you are taking, if you are suspend the magnet always, if you are suspend the magnet, so I'm considering I'm suspend the magnet here like this. So it always shows north and south direction. So it won't show exactly north and south. It shows somewhat tilted, somewhat tilted, somewhat tilted. It shows. Okay, so north and south we can observe. We can consider. We can. So by that we can identify the north and south directions. Okay, so that's enough. That is about magnet, north pole and south pole, and that is about a directive property. Coming to the magnetic field. So the magnetic field we will discuss. So the region around the magnet in which magnetic force exert, the region around the magnet in which magnetic field exert. Okay, so I'm considering this a magnet. So I'm considering the magnet. So this is the magnet here like this. So I'm considering this a magnet. Okay, this is the magnet. So here I am taking the north pole and here I am considering south pole. North and south pole. North and south pole I am considering. Okay, so this is the north pole and this is south pole. So around the magnet, magnetic field will be there. Around the magnet, magnetic field will be there. Okay, so I'm considering here. Around the magnet, magnetic field will be there. So here you can see. So this I am taking like this. So I'm considering. So this is north. and this is south. Around the magnet, magnetic field will be there. Around the magnet, magnetic field will be there. So I'm considering here around this magnet, the magnetic field will be there. So here like this, around this magnet, the magnetic field will be there. Around this magnet, magnetic field will be there. So the region around the magnet in which magnetic force exert, the region around the magnet in which magnetic force exert, that is called magnetic field. The region around the magnet in which magnetic force exert, the region around the magnet in which magnetic force exert, the region around the magnet in which magnetic force exert, that is called magnetic field. The region around the magnet in which the magnetic field exerts, that is called magnetic field. So around the magnetic field will be there. Around the magnet, the magnetic field will be there. Around the magnet, the magnetic field will be there. Okay, so around the magnetic field will be there. The magnetic field will be in the form of field lines. The magnetic field will be in the form of field lines. The magnetic field will be in the form of field lines I'm considering. Okay, so the magnetic field will be in the form of field lines. Okay, so here I'm considering this around the magnetic field will be there. Around the magnetic field will be there. So here you can see the magnetic field will be in the form of field lines. The magnetic field will be in the form of field lines. I'm considering like this. So the magnetic field will be in the form of field lines. So like this. So field lines around the magnetic field lines will be there. So here I'm considering the magnetic field. Here I'm considering the magnetic field. Okay, so the magnetic field around the magnet in the form of field lines. So here magnetic field lines start from North Pole to South Pole, and here reaches to magnetic field lines will start from North Pole and reaches to South Pole. Magnetic field lines start from North Pole and reaches to South Pole. Okay, so this is about a magnetic field direction, and here magnetic field lines never intersect. So here you can see magnetic field lines never intersect. So there are properties are there, magnetic field lines properties are there. So I am talking about magnetic field line properties. So magnetic field lines start from North Pole and reaches to South Pole. Magnetic field lines start from North Pole and reaches to South Pole. So that's the first point. And coming to the second point. Second point is simple point is that is nothing but the magnetic field lines never intersect. Magnetic field lines never intersect. If it is intersect, so compass should show two directions at a time. Where it is not possible. Okay. So here I am taking the magnetic field. Here I am considering the magnetic field. So around the magnetic field, magnetic field will be there. The magnetic field lines start from the North Pole and reaches to South Pole. Magnetic field lines never intersect. So these are closed loops. If it is intersect, so what happens? If it is intersect, so at the point of intersections, compass should show two directions at a time, where it is not possible. So at the point of intersection, compass should show two directions where it is not possible. So that is the reason. So magnetic compass does not magnetic field lines never intersect. And I'm coming to the next one. So this is about magnetic field. Around the magnetic field lines and properties, how the field lines will be there. So if you see at particular point, if you are taking the direction of the magnetic field at the point, so if you are taking in the field, if you are considering, so at this point, if you want to find out the magnetic field direction, so we can draw the tangent. If you draw the tangent, So the magnetic field direction at that point, it will be identified. So if you draw the tangent to the magnetic field lines, so at that point the field lines will be there. So the field line direction will be there. At that point, the field line direction will be there. So that is about a magnetic field. So magnetic field direction. And coming to the next one, so we are going to the current carrying through straight conductor. If the current is passing through the straight conductor, how the magnetic field will be there? How the magnetic field will be there in around? See, already you said. So this is about magnet. Complete now. Till now we discussed about a magnetic property. So natural magnet and artificial magnets. Now we will discuss about if the current is passing through the conductor. If the current is passing through the conductor, how it will behave, how it will produce, what it will produce. So a current carrying conductor acts as a magnet. So normally we know electromagnets. If you are taking the iron nail and wound the copper wire around it, wound the copper wire around it, so connect to the battery, then what happens? So it acts as a magnet. It acts as a magnet. So here only I'm talking about the magnetic effects of electric current. That is nothing but when the current is passing through the conductor. So when the current is passing through the conductor, the conductor exhibit magnetic field. 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 So that is about magnetic field. That is about magnetic field. Okay, so around the current carrying conductor, so magnetic field will be produced. So in which direction it will produce, how it will produce, what rule we will use to identify the direction of the magnetic field, now I will discuss. Normally if you are taking the conductor, so I am considering the conductor like this. Okay, so here I am taking the conductor. This is the straight conductor. I am considering. This is the straight conductor. Okay, so this is a straight conductor. If this is a rheostat, I am considering the ammeter here. So here I am considering the battery. So switch, current will pass. So current is passing. Okay, so this is the rheostat. A rheostat is nothing but variable resistance. Rheostat is nothing but variable resistance. Here I am taking the conductor. So here I am considering the conductor. So this is the conductor, straight conductor. So I am considering this a straight conductor. So straight conductor, current is passing like this. So if the current is passing, so this acts as a magnet. It produces around it magnetic field will be produced. So around it magnetic field will be produced. So okay. So I am considering like this. Okay. So I am considering like this. Around the conductor, the magnetic field will be produced. So here I am considering the compass. This is the compass. So what is compass? So compass is nothing but you can see compass is also a magnet. Okay, so inside magnetic needle is present. So you can observe the compass. If you observe, so it always shows north and south direction because it is a magnet. A small magnetic needle is present inside of it. So that's why if you place normally also, it always shows north and south direction. So compass, if you place normally, if you suspend normally, it always shows north and south direction. Here I am considering, so current is passing like this. Okay, so here a magnetic field will be created. Around it magnetic field will be created. around it magnetic field will be created. Okay, so around it magnetic field will be created. So what type of, see, around it magnetic field will be created, right? So we know north pole and south pole. This is north and this is south, east and west. So north, south, east and west, 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 north, south, east and west. Okay, so here you can see north and south, east and west. See, if the current is passing from positive terminal to negative terminal, if the current is passing from positive terminal to negative terminal, positive terminal to negative terminal current is passing. Yes or no? Yes. Magnetic field is created around the conductor. Yes or no? Yes. Magnetic field is created. So here you need to understand one thing. Here you need to understand one thing. If the current direction changes, the polarity of the battery changes automatically. If the polarity of the battery changes, automatically magnetic field direction also changes. If the polarity of the battery changes, magnetic field direction also changes. If the polarity of the battery changes, if you are changing the direction of the current, magnetic field direction also changes. So here, how it will be changes, what rule we will use to identify the magnetic field around the straight conductor, around the conductor, we will discuss. That is the right hand thumb rule. By using right hand thumb rule, listen carefully, listen, are you listening or not? Are you listening or not carefully? So listen carefully. Right hand thumb rule. So right hand thumb rule. Right hand thumb rule is nothing but I will explain first. If the, so you know, right, if the current is passing through the conductor, so are you listening? Are you listening? It's very, very important. If the current is passing through the conductor, magnetic field will be created around it. Magnetic field will be created around it. Magnetic field will be created around it. So here I'm considering around the conductor magnetic field will be created. So by using compass we can identify. So here you can see, so if the current is passing in this direction, so anti-clockwise direction, so you can see, so this is the clockwise direction, clockwise, this is the clockwise. So if you are taking this anti-clockwise direction, opposite, so this is a normal clockwise direction, this is anti-clockwise direction. If the current is passing along this direction, if the current is passing along this direction, the current is passing along the direction, the deflection in the magnetic field, the deflection in the magnetic field, in the magnetic field, the deflection in the magnetic field will be towards west. The deflection in the magnetic field will be towards west. The deflection in the magnetic field will be towards west. So the magnetic compass shows deflection towards west, deflection towards west. So like, see, it shows deflection towards west. I'm changing the polarity. If I change the polarity, so like this I'm considering current is passing, like this I'm considering current is passing, like this I'm considering current is passing, current is passing from so it is not a head pain, so it is symbol of confidence. Always show your head high, like it's okay. So we have to, this is the symbol, this is a symbol for confidence, strength, ability. Okay, and so like so many, we with this only we can express many things. Okay, so farmer, you can see farmer, so he will cultivate, so he is doing cultivation, right? He will tie this cloth to the head, because he is going to, it's like a more than a war. Okay, so by that, so we are getting food. So that's enough. This is respect, confidence, ability, strength. That is the reason. So understood? It's more than that. Okay. So Swami Vivekananda, he went to the USA with this one. Okay. So with the, so I don't want to tell so many points. So yeah, I hope you got it. So you can observe Swami Vivekananda. So he tied that one. Okay. So and went and went and spoke in Chicago in the entire all dignities, in front of all dignities. So dear brothers and sisters of America, before that no one addressed in that way. No one addressed. So then he started his journey. So it shows that more than that. That's enough. So come to the point. Come to the point. So next one, if the current is passing through this one, if the current is passing through that one, so current is passing like this. So from positive terminal to negative terminal, current is passing from positive terminal to negative terminal, current is passing from positive terminal to negative terminal. So the magnetic field, you can see this you can see this magnetic field direction towards west. The magnetic field will be towards west direction. So if you change the polarity, the magnetic field will move around the clockwise direction. The magnetic field will move clockwise direction, anti-clockwise direction, clockwise direction, anti-clockwise direction, clockwise direction, anti-clockwise direction, clockwise direction. If the current passes anti-clockwise direction, the compass should show direction towards the west. If the current passes clockwise direction, magnetic field compass should show towards west. So by this we can conclude that, only one thing. What is that? What is that? If you change the current direction, if you change the battery polarities, current direction changes. If you change the battery polarities, current direction changes. By that, magnetic field direction also changes. If you change the current direction, magnetic field direction also changes. So we can conclude that so from here, if the current is passing anti-clockwise direction, anti-clockwise direction, compass should show towards west direction. So if the compass shows if the current passes clockwise direction, 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 so magnetic compass should show towards east direction. So by this we can conclude that only one thing. So what is that? We can conclude that if you change the current direction, automatically magnetic field direction also changes. If you change the current direction, automatically magnetic field direction also changes. I hope it is clear to you all. So now I'm going to the next one, magnetic effects of electric current. So this is about side conductor. Now by using right hand thumb rule, 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 right hand thumb rule. What is it showing? What is it telling? If you lift your thumb along the conductor, along the current direction, if you curl the fingers, along the curling fingers, Along the curly fingers, magnetic field will be there. Magnetic field will be there. Magnetic field will be there. In the direction of curly fingers. This is the thumb along the conductor. Along the conductor. Curly fingers showing magnetic field. Okay, so we can understand, we can conclude that only one, that is super one, right hand thumb rule. So what is the right hand thumb rule? Right hand thumb rule is the simple one is, if you are taking the right hand along the conductor, along the current direction, along the current direction, if you are wrapping the fingers, if you are wrapping the fingers along the wrapping finger direction, 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 along the curly fingers, along the curly fingers, along the curly fingers, along the curly fingers, along the curly fingers. If you're taking thumb along the conductor direction, if you're taking the thumb along the conductor direction, curly finger showing magnetic field, curly finger showing magnetic field. So this is called right hand thumb rule. This is called a right hand thumb rule. So if you are taking the right hand along the current carrying conductor direction, along the current direction, so curly finger shows magnetic field. Curly finger shows magnetic field. So what is this rule? Right hand thumb rule. What is this rule? Right hand thumb rule. This is my right hand. This is the thumb. That is rule. That's enough. Simple. Very easy. Like that. That's enough. Very easy. Very, 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 very easy. Very, 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 very easy. That much easy. How much? That much easy. So simple only, right? So you are taking the thumb, you are taking the curly fingers. So along the conductor direction, you are placing the thumb. Along the conductor direction, you are placing the thumb. Along the conductor direction, you are placing the thumb. Curly finger showing magnetic field. Curly finger showing magnetic field. Curly finger showing the magnetic field. So if you are taking the thumb along the current direction, curly finger shows the magnetic field direction. So by this we can conclude that, okay, so thumb shows the current direction, curly finger shows the magnetic field of right hand. Of right hand. Of what? Right hand. Understood? This is my right hand. This is the strength. Okay, so this is the thumb along the conductor, curly fingers along the magnetic. If you learn, you'll get 1 mark. Done. So come to the point, next one. So I am taking the conductor along this direction. This is the conductor. So I hope this is the conductor. So I am taking the magnetic field will be like this. Magnetic field will be like this. Okay. So if your current direction is downward direction, so magnetic field will be like this. If you are taking the current upward direction, so magnetic field will be like this. So you are drawing the lines, you are drawing the curves. How the magnetic field will be, how the magnetic field will be considered, how we have to take the magnetic field, how we have to take the magnetic field. So the point is only one thing. The point is only one thing. If you are taking the thumb, so place along the thumb direction. So if you are considering along this direction, so along this direction, along the current direction. So if you are placing the thumb and the curly finger shows the magnetic field direction. If you are placing like this, so this is clockwise or anti-clockwise? Anti-clockwise. If you are seeing like this, anti-clockwise. If you are seeing like this, anti-clockwise direction. So if it is like this, clockwise direction. If you are like this, like clockwise direction. Okay. So clockwise direction. So it depends. And one more thing, there is a question. So they will ask about with respect to north and south. 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 North and south. North and south. I am taking north and south. This is north. This is south. East. West. North, south, east, west. North, south, east, west. So if the current is passing upward direction, the magnetic field will be from east to west. If you are taking the current upward direction, magnetic field will be, if you are taking the current upward direction, magnetic field will be east to west. If you are taking the current downward direction, if you are taking the current downward direction, so east to west, sorry, west to east, west to east. So like that sometimes, so they will ask about magnetic field. So they will ask, sometimes they will ask about the magnetic field above the wire, below the wire. Magnetic field we have to take above the wire and below the wire also they will ask. So that also we have to do it. So this is about right hand thumb rule. This is about right hand thumb rule. So generally we discussed about current carrying through straight conductor. Current carrying through straight conductor. If you are taking the loop, if you are taking the loop, if you are considering the loop, I am considering this the loop. So this is the loop. So positive terminal, negative terminal, current is passing like this. Current is passing like this. Positive terminal to negative terminal, current is passing. Positive terminal to negative terminal, current is passing. Current is passing. Positive terminal to negative terminal, current is passing. Current is passing in the conductor. In the conductor. What is that conductor called? Electromagnet. Electromagnet. Current is passing in the conductor. That conductor is called electromagnet. So when the current is passing in the conductor, it acts as a magnet, that is called electromagnet. Here I am taking the current is passing in the conductor. So here the magnetic field will be produced. So anyway, we understood one thing: if the current is passing through the conductor, magnetic field will be produced, right? So I am considering here. Sir, Shiva sir, Shiva sir, Shiva sir, I have one question. Shiva sir, Shiva sir, I have one question, sir. What is that? What is that question, sir? Shiva sir. So where the magnetic field will be more, sir? Where the magnetic field will be more, sir? Now I will explain. Sir, one more doubt, sir. In the conductor, magnetic field is flowing, sir. Magnetic field is so passing, right? So it produces magnetic field, right? Yes, sir, no? It is producing magnetic field. So we can say that is electromagnet or magnet, sir. When the current is passing through the conductor, it acts as a electromagnet. It acts as an electromagnet. Why? When the current is passing, because of current flow only, conductor is current flow only. So the conductor act as a magnet. So that's why it is called electromagnet. Sir, thank you so much, sir. So shall I continue on the next one? Sir, you can continue, sir. Okay, done. So now I am taking, so here I am considering, so current is passing like this, So positive terminal to negative terminal, positive terminal to negative terminal. So here the magnetic field will be there. So I am considering here, in this case, it will be like this. So here I am considering like this. So magnetic field will be leaving this side and leaving this side. So this is north and this is the south. North-south, because the magnetic field is reaching to this one. The magnetic field is reaching to this one. You can consider, sir. How can we consider, sir? I have doubts, sir. Sir, how you will do it, sir, in the loop? So how you will do it, sir? With what rule we will use, sir? So please tell me, sir. So actually, when the current is passing in the conductor, we will use the right hand thumb rule. So we know that the right hand, this is the right hand thumb rule, this is the thumb, these are the curly fingers, these are the curly fingers. So if you place the thumb along the current direction, so if the current is passing like this, so magnetic field will be like this, magnetic field. So here downward direction, here the current is passing upward direction, magnetic field will be. Sir, one more question, sir. Sir, magnetic field will be more at the circumference or at the center, sir? Sir, one question, sir. Sir, magnetic field will be more at the center or circumference? Sir, one question, sir. Magnetic field. So I'm repeating my question, sir. So please listen, sir. So magnetic field will be more at the center or circumference, sir. Okay, so I'll explain this question. Listen. So here I'm considering the magnetic field will be more at this point, so at the center. So it is not at the circumference. The magnetic field will be more at the center. So why? So when the light ray, when the magnetic field will be moving, so here I'm taking current is passing like this, current is passing like this. So when you keep on moving, it will become parallel lines. So here it will become parallel lines, 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 here it will become parallel lines. So when the parallel lines here, so I am taking here, so I am considering these are the three markers. So here you can observe these are the three markers. So this field will be add up to this one. So if the field lines are parallel to each other, if the magnetic field lines are parallel to each other, this field will be add up to this one, this will be add up to this one, this will be like this. So here this magnetic field lines, so magnetic field will be add up one each other, so the magnetic field will be more. So here the magnetic field is uniform, the magnetic field will be uniform. At the circumference the magnetic field will be less, at the center it will be more. Sir, thank you so much, sir. I'm very happy, sir. So nice, sir. That is, so magnetic field will be more at the center, no, sir? Yes. So magnetic field will be more at the center. So thank you so much, sir. Now I'm going to the next one. Next topic is, so we can take loop is completed. So I'll explain about solenoid. Sir, what is solenoid, sir? What is solenoid? Solenoid is nothing but if you are taking the straight wire, so bent in the form of cylindrical shape. So take the straight wire bent in the form of cylindrical shape, connect to the battery. Sir, here insulated or without insulation, sir? So we have to insulated wire, insulated copper wire only, because when the current is passing anyway it act as a magnet. Okay, so we are wrapping, so like a wrapping like a cylindrical shape, connect to the battery, it act as a magnet, okay. So it act as a magnet. Sir, one question, sir. The question is, sir, you are saying you are taking the straight wire bent in the form of cylindrical shape, connect to the battery, it act as a magnet. Sir, is it this magnet will be same as a bar magnet, or the properties will be same? Oh, very good. So you are getting nice doubts, Shiva. You are getting very nice doubts. So nice, that is correct only. So whatever you are taking the solenoid, if you are saying right, that solenoid, however it will produce properties, same properties will be having the bar magnet. What are the bar magnet have? Artificial magnet have. Same thing here also. Here also solenoid. So it act as a magnet. It has poles. North and south. And one more thing also, if you suspend this solenoid, it act as a bar magnet. Sir, thank you so much, sir. So I'm very happy it is, sir. Sir, one question, sir. Sir, here solenoid you said no, sir. But for bar magnet, north and south poles are there, sir. North and south poles are there. But solenoid, how can you identify the poles, sir? How can we identify the poles, sir? Can you explain that one, sir? So, Shiva, okay, Shiva. So you are getting more doubts. So you will be having more doubts. That's why I'll explain solenoid. Now I will explain solenoid. Listen carefully, sir. Okay, sir. Thank you, sir. Please explain, sir. So here, solenoid I will explain now. Now you can check. So very, very interesting topic, Shiva. So be careful, listen careful. So observe here. So I'm considering here solenoid I'm taking the solenoid. So here I'm considering the solenoid here. So take this Sir, one more doubt, sir. Sir, how many lines we have to take, sir? You did 10 lines there. How many lines we have to take? So, generally, Shiva, we can take 5 lines, 7 lines, and 9 lines also okay. Because those are, you can take according to your, but diagrams must be good. So, however lines you can take, but diagrams must be good. So, I'm taking here. So here you can observe current is passing like this. Current is passing like this. It act as a magnet. So here you can see in this bar magnet. So uniform magnetic field will be there. Uniform magnetic field will be there. So current is passing here. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance opposite to above the principal axis. Distance are negative below the principal axis. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. So like that, I hope you got it. So this is about the solenoid. Solenoid we are discussing. So object. So it act as a magnet. So whatever you are taking for bar magnet also same it produce. So until here solenoid. So we'll see the next class solenoid we are discussing, right? So live class will be there. So in the next live class I will explain about remaining points. So until then, thank you.